Hello everyone. In this video lesson, I will talk to you about Cahn-Ingold-Prelog priority rules, which helps us to determine geometric isomers configuration. In this video, we will determine E or Z configuration of a given alkene. Let's find out the longest carbon chain first. 1, 2, 3, 4, 5, 6 is the longest carbon chain, and I will number this longest chain starting from this side, because this carbon has a carbonyl group, and then comes a pi bond. Number 1, 2, 3, 4, 5, 6. So 6 carbon containing molecules, we call it hexane. Hex. At the 3 position, there is an alkene pi bond. I will just hexane, and at the 2 position, there is a carbonyl group, which makes this molecule a ketone, hexane non. At the 3 position and 4th position, there is a methyl group. So I have to add this 3, 4 dimethyl. Okay, this is the name of this molecule. Once we determine E or Z configuration, the naming is complete. To determine the E or Z configuration of this alkene molecule, C3 and C4 carbon. Let's start with C4 carbon. C4 carbon has ethyl group and methyl group. To determine EZ configuration, we will look at the atoms that are directly bonded to this C4. Okay, directly bonded to this C4 is carbon atom at C5. Directly bonded. Okay, carbon of ethyl group. carbon of methyl group also directly bonded to C4. So there is a tie here. There is a draw. I cannot tell the priority of this two group. So I have to look at the next atom or atoms connected to these carbon atoms. Okay, C carbon atom of ethyl group has a hydrogen atom, and a carbon atom. Let's move this little bit down. Methyl carbon has 3 hydrogen. So first rule in Cahn-Ingold-Prelog priority rules, look at the directly bonded atoms. Biggest atomic number takes the highest priority. Both are carbon atoms connected directly to the C4. So I cannot decide a priority. So I have to look at the next atoms connected to these carbon atoms. As you can see, in ethyl, there are 2 hydrogen connected, 1 carbon atom connected to this carbon. But in methyl, there are 3 hydrogen atoms are connected to this carbon atom. So priority, highest priority is this one. Number 1 is ethyl group. Number 2 is methyl group on the C4 carbon. Let's look at the C3 carbon. C3 carbon, this is C3 carbon, has a methyl group and acetyl group. So C3 carbon is connected to this carbon atom in methyl, connected to this carbon atom in acetyl group. So both groups contains carbon atoms. So there is also a tie here, which you cannot decide which group has a priority. So I have to look at the next atoms. Methyl carbon, this is the carbon. This methyl carbon has 3 hydrogens. This carbon connected to 3 hydrogen atoms. this carbon atom has 2 oxygen atoms. I will show this like this, double bond, and 1 carbon atom. As you can see, acetyl group has oxygen atom and carbon atom. Therefore, this acetyl group has the biggest priority. Number 1. Methyl group has the lowest priority. So, if two highest priority groups are opposite to each other, then we call this configuration, as you can see, opposite E, opposite E configuration. So this alkane has an E configuration. Let me just put these priorities. This C4 has ethyl group and methyl group. As you can see, ethyl group has the highest priority, which we call this number 1. Methyl group has the lowest priority. When I go to C3, C3 has a methyl and acetyl group. Methyl group has the lowest priority. Acetyl group has a highest priority. As you can see, highest priority groups are opposite to each other. This group and this group opposite to each other. If I draw X, Y coordinates, ethyl group is on the Y coordinates plus acetyl group on the minus Y coordinate. So that is the name of this molecule. That's it. In this video lesson, we have learned how to determine EZ configuration of alkanes.